Esteemed participants, I greet you with respect and gratitude for your kind presence on this platform. I sincerely thank you for devoting your time to reviewing my poster related to my research topic entitled Thermal Diffusivity Measurements of Polycaprolactonemembranes by means of Photoacoustic Techniques. I am Yavasul Sanchez from the National Polytechnic Institute of the Interdisciplinary Professional Unit of Biotechnology. Let us commence. Well, by way of introduction of this research, a self-normalized photoacoustic technique is employed to measure the thermal properties of polycaprolactone membranes obtained through electrospinning. This technique enables us to indirectly measure temperature fluctuation within the sample, resulting from non-radiative excitation following modulated radiation absorption. The membranes were observed using SEM to calculate their average size. Moving into the material and method section, the first step involves the preparation of the polymer solution. To achieve this, a previously determined amount of polycaprolactone is dissolved in 15 milliliters of acetone, maintaining constant agitation and the temperature of 50 degrees Celsius. The first process is carried out until a viscous solution is obtained, which is subsequently stored in a container for a later use in the electrospinning technique. In total, 8 solutions were prepared and their specific details are outlined in Table 1. Now, delving into the electrospinning technique intended for adhering polycaprolactone membranes, it was ascertained that a voltage of 15 kilovolts proved to be the most fitting for the creation of these membranes. Furthermore, upholding a uniform distance between the needle and the collector was considered vital to obtain membrane fabrication. Uh, the detailed aspects of this process are outlined in Table 2. In Table 2, sorry. Figure 1 shows guys a systematic representation of the electrospinning system for your consideration. Turning our attention to the self-normalized photoacoustic technique, this approach is grounded in the signal correlation between experimental photoacoustic setups on the front and real surface of the material, as depicted in Figure 2. This establishes reliable criteria for confirming the detection of the photoacoustic signal. Temperature fluctuations on both material surfaces are regulated by heat transfer equations. We enter the results section, commencing with the measurements of photoacoustic amplitudes and phases. An area of 1 plus 1 centimeter was selected on the membrane, and a black pigment was added using a marker. Following that, the membrane was placed in the photoacoustic cell and positioned in front of the laser, as can be observed in Figure 3. The measurements of thermal diffusivity was carried out. Once these measurements was completed, a more detailed analysis of the obtained results was conducted. Through mathematical analysis, it is possible to calculate the thermal diffusivity of the material at the moment when the first discontinuity occurs, which can be observed in figure number 4. Once the first discontinuity is identified, equation 1 is applied. In this equation, the letter F represents the frequency at which the first discontinuity occurs, and the letter L denotes the thickness of the sample obtained the thickness of the sample obtained using a micrometer. This procedure allows for the determination of the thermal diffusivity of polycaprolactone membranes. Within the same accurate images, a measurement of membrane size is conducted followed by an averaging process to determine the mean membrane size. In Figure 5, we can observe two distinct images of the same membrane alongside the histogram depicting the mean membrane size. In conclusion, we can state that the thermal diffusivity of polycaprolactone membranes using the self-normalized photoacoustic technique has yielded promising results. However, we continue to work towards establishing the relationship between the thermal diffusivity of the membranes and their average size, which could provide valuable insights for various applications. I extended my gratitude for your attention.